Good afternoon to all my teachers and principals are present here, and all my juniors and my classmates are present here as well. Today, we have gathered here to discuss about the importance of mechanical engineering. And personally, for me, this topic is very personal because throughout my engineering, the questions that have been addressed here have been asked to me by my friends from the CS department and my ECE department, and the response was always that it is not how it looks. Mechanical engineering has its fair share of opportunities. Well, let's talk about a few opportunities later on. Let me talk about the latest advancement or the latest branch of technology which has come out of mechanical engineering, which is nanotechnology. Let me quickly run you through the content of today's presentation. So it is going to go from nanotechnology. We are going to learn what nanotechnology is and a few advancements of nanotechnology and its applications. And then we'll go to advancements in mechanical engineering, where my friend will explain you the various advancements other than nanotechnology which has happened in mechanical engineering. And finally, my friend Mayuk will explain to you the opportunities as an entrepreneur, like being a mechanical engineer, how much opportunities you get to become an entrepreneur. Okay, so before we start to learn about nanotechnology, we need to understand what is nanotechnology. So here's an image that will help you appreciate what as scientists and engineers we have achieved. So over here, Rohan, could you just confirm that everybody can see, if you can see my mouse cursor?
Yeah, I can see your mouse cursor very clearly.
Okay, thank you. So over here we can see that there is the ant, approximate length 5 millimeters. Smaller than that, we'll find a dust mite, 200, 200 micrometers. Then even smaller, when we go even smaller than that, then we'll find a human hair. The thickness of a human hair will go from anything between 10 to 50 micrometers. Then we have, yeah. Then we have red blood cells over here, which is even smaller, which goes from 2 to 5 micrometers. Then we can see over here that we have a DNA structure. Now, right between our DNA structure and our blood cells, there's a region. There's a region which is between 10 to the power minus 7 and 10 to the power minus 10. That is where nanotechnology happens. As we can read over here, that 1 nanometer is about the length which our fingernail grows in 1 second. So it is unimaginably small, and that is how small we can compress technology. And this has not been pre-existing for entirety. We have developed this in less than 100 years. This is why I want everyone over here in this meeting to appreciate how much as engineers and scientists we have achieved over here, right? Okay, now that we have understood what nanotechnology is any technology which operates or functions in a length below 10 to the power minus 10 to the power minus 9 meters. Now let's look at nanotechnology as a whole. So as I already told you, nanotechnology is any machine or any robot which functions or any process which functions at a very small space, anywhere between 10 to the power minus 9, and it could be even smaller than that. Now its application can be anywhere and everywhere you can look at. Nanotechnology has been explained by many experts in this field as a household name for the future, just how plastic has become now. Because let's face it, nanofabrics, a lot of us have worn nanofabric without even knowing it. We have all had ads of self-cleaning t-shirts or self-drying t-shirts. Now, how's that achieved? Common cotton or the general cotton that is produced cannot do that. That is where nanotechnology comes in. Okay, so it is nanotechnology has branched off from mechanical engineering, but I should not forget to mention that it epitomizes knowledge from biology, be it physics, be it chemistry, and of course mechanical engineering. It is not just a single-handed contribution of mechanical engineering, of course. Now, this technology has been used, changed, interchanged, iterated upon to fit different technological verticals so as to get the most profitability out of this technology. Let's look at some examples of what we have achieved through nanotechnology so far. Now, to start with, to give you a little connection about nanotechnology and how mechanical engineering, what nanotechnology and mechanical engineering together has achieved. So, design and production of nanomaterials always uses mechanical engineering. So, you over there you can hold a loop, right? Now, carbon nanomaterials are being used for aerospace engineering. Now, I don't have to tell you that heavy materials don't fly. So, we need lighter materials to make our planes, and this struggle to find ever lighter materials has been there from right when Wright brothers have invented the plane, and ever since that we have been searching for lighter and lighter materials to build our planes with, so that they fly other distances with less fuel. Now, thirdly, I would like to tell you about 3D printing and nanotechnology. And over here, you can read by yourself that a university which goes by the name Rutgers University in USA Research has developed a way of binding nanoparticles using 3D technology. Now, what this is going to do is it is going to bring down the cost and manufacturing of nanotechnology, nanotechnology such as your touchscreen AMOLED screen on your phone. That is nanotechnology. That is the example of nanotechnology. This is why previously I had already mentioned that a lot of us use nanotechnology even without knowing it. Now, another vertical where nanotechnology has tremendously or will tremendously eventually affect the industry is thermal engineering. Now, if a lot of you being from first year or second year or trying to get into mechanical engineering don't know that heat, which is produced as a byproduct, is not liked or appreciated. So we try to get that heat out as soon as possible. But the current technology which we use is making fins, or in short, or in simplicity, increasing the surface area. This is why on the surface of a motor you'll see layers of spikes, which are long spikes, right? Those are called fins. They have no other function other than heat ejection, right? But that technology has existed for a long time now, and it is finally being challenged now by nanoparticles. Over here you can read that using nanoparticles, almost 100% thermal conductivity using liquid coolants can be achieved, and this has attracted a lot of companies to adapt nanotechnology in their production. Now, another thing before I go to the next slide is fuel production. Now, fuel production has always been a problem for our society. USA does not invest heavily in the Midwest just for international relations. Oil is one of the reasons, right? So oil has always been a very controversial fuel all around the world. Okay, just a second, sir. I would like to apologize. My battery ran out. Just give me a few seconds. I'll. Um, can you hear me?
Yeah, you're audible.
Yes, you are audible.
Yeah. Okay. Okay. So I'll just resume from where I was. Sorry, guys, for the delay. I should have been more careful. I'm sorry about that. So where were we? Let me just switch off my.
Nanotechnology is a fuel.
Yeah. Let me just switch off my ceiling fan so that everyone can hear me loud and clear without any disturbation. So yeah. So where was I? Yeah, fuel production. So fuel has always been game-changing, resource to have. The world wars that happened were also won due to the oil availability that the Allied power had. If nobody knew about this, then this is just a fact. We learn something new every day. And now nanotechnology is being brought into fuel production, and nanotechnology can be used to gather like fuel and extract it out of the ore or the raw material, so that at the end customers get the fuel at a cheaper price, right? Now if I want to go on and on, then we will probably be sitting here till dawn, you know, because nanotechnology can essentially be applied to anything, be it the energy sector, be it optical engineering, be it the defense sector, and I've already mentioned about nanofabric, and of course cosmetics also has a good amount of nanotechnology involved. But so what I'm going to do is uh, I'm going to go for the technological vertical that I like the most, so that the words that I speak can come out of passion. Okay. Okay. So fuel cells is something. Fuel cells is something where I feel that nanotechnology is going to bring a tremendous impact, and we should all prepare ourselves. Now we all know what a fuel cell is. We have studied it in our class 11 and 12. If there is someone who does not know what a fuel cell is, well, fuel cell is an electrochemical cell, or a battery in short, that converts mostly hydrogen and oxygen to give out a redox reaction and electricity as a byproduct. Now this over here is a fuel cell, and over here we can see a membrane. Now innovation using nanotechnology has happened on two parts. Now first of all, I would like to go with you on the membrane. Now what the membrane is made of in general cases in a fuel cell, if I'm speaking to a layman, is made out of platinum. Now platinum is a very expensive material, and what now industry is trying to do is replace this platinum with nanoparticles of platinum or nano ops of other materials, so as to eliminate the need or the requirement of platinum altogether. Now the second thing that I would like to cover is that the catalyst of fuel cells is also trying to be a problem when we are trying to implement them in our modern cars, because the catalyst which is used in fuel cells is also platinum, and is actually a big chunk of the cost which goes into making a fuel cell actually goes into buying and securing the platinum. Now if nanoparticles of platinum or any other material which shows the same properties such as platinum can be found, then we can imagine a world where fuel will not be required to run our automobiles, and they can entirely run using renewable energy sources. Now, sorry. Let me show. So this is another vertical where nanotechnology has promised for a greater future. Now, I have talked about how nanotechnology can be implemented on cells of a car or a battery of a car, so as to increase the longevity and the efficiency, so that electric cars go a greater distance and perform better. Now, if a lot of people don't know over here, being in first year or second year, then the biggest problem to switch to electric cars right now is that electric cars they don't give a great mileage as well as those running on diesel or petrol does. Now, what scientists at Tesla and I believe other automobile giants will soon add in, they are researching for a material which sticks to the exoskeleton of the car or the surface of the car and acts as a battery. Now we can over here we can see over here, observe that the upper layer is supposed to be carbon fiber, and fiberglass is supposed to be a membrane. As I showed you, fuel cell also needs a membrane to separate the positive from the negative. So carbon fiber can act on the top, and carbon fiber can also act on the bottom, and fiberglass can act as a membrane and act as a battery in total. Now what this will do is it will make the car lighter, help the car achieve greater mileage, and also it will make a world without fuel without being dependent on fuels such as petrol or diesel actually possible, right? So there are other advancements happening in mechanical engineering all around the world all the time, and I would like to bring my friend Rohan Verma in to talk to you about and explain to you about the various advancements in mechanical engineering other than nanotechnology, that is. Rohan, can we please have
Yeah,
you here?
yeah, please. So, as Vijit has already introduced you to nanotechnology, let me cover biomimicking 4D technology and scramjet very quickly and very efficiently. What is biomimicking? You already know about bio. It's about biodiversity, nature, and animals. So, what we are right now, scientists are doing, they are following the nature. They are seeing what the animals are doing, what is going on about in our nature, and then getting inspired to build something out of it. For example, scientist in USA is being inspired by cockroaches to build robots which can travel into different terrains, being mountain, being anywhere. These will help us to ensure our environment and also the search and rescue operations. There are sensors being organized by or inspired by butterflies, which will help us to increase the censoring of bombs and all, which will reduce the cost of metal detectors and every aeroports securities and all by a lot. By a lot, by margin is 100 times lot. Now, what is 4D technology? 4D technology is nothing but an advanced form of 3D technology in which you can just print anything which can change its shape in with time. With time. Now, the team which is working on this includes, but not limited to, MIT, one of the premier leading mechanical engineering college, and Harvard's Waste Institute. With this, you can programmable materials which will change its shape depending on the size and situation and the stimulus that you apply to the tea. So, Vijay, can you kindly change the slide so we can cover on to the next topic? Vijay, change the slide. Vijay, next slide. Oh, so last I would covering is scramjet. Scramjet is supersonic combustion ramjet. As you already know, ramjet. What is ramjet? Which is being used in rockets, which gives it extra speed to cross our terrestrial atmosphere and go on to other planets and research or for development. Right now, our rockets are at a speed of 7,400 kilometer, and with the scramjet, it will reach to a speed of 17,890 kilometer per hour, which will ensure us to go beyond Mars from to Jupiter and Neptune and Saturn. Also, right now it takes almost 17, 18 hours to travel from India to USA. When once scramjet is out, as applied by NASA, it will take us just 7 hours to travel from India to USA with a speed of over 7,890 kilometers. You can so below is the plane which is NASA working on is X-43A plane. Now, as we have already talked about advancement, now I will give it to Mayuk to contribute about opportunities as an entrepreneur. Please, Mayuk, can you take over and continue?
Thanks, Rohan. And now I am going to carry forward the PPT from here. So let me tell you the audience that who are the entrepreneurs. Actually, they are that person who takes the financial and market risks with the unique ideas, with unique business ideas, and uses the modern technology to achieve any goal, to achieve any dream, for making profit, for serving the mankind, for serving the world as well as our nation. So if we can, if we look into the field of mechanical engineering, we can find many of them. As I would like to tell that a mechanical engineer is responsible for various tasks like analyzing the issues to determine how a device can solve any problem, or we can also recommend the remedies when there is any fault in the equipments. And on the basis of this problem solving skills, on the basis of the creativity, on the basis of the knowledge that we have gained during our BTech, during MTech, or the higher studies in mechanical engineering, we can use that knowledges in many kind of entrepreneurships. Like in this slide, we can see there are 7 topics. Now, I would like to tell about I would like to tell something about the nut and bolt mechanism and this kind of farms. Like the demand of the fastener technology, like nuts and bolts are there, is very high in our modern world. Like a report recently that has been published, they had said that the demand is going to a market value of 7,703 billion by the end of 2023. So there is a huge scope if you are going to do any entrepreneurship, then this would be a perfect platform for you. Now, I would like to tell something about the supply chain management. Now, it involves a series of activities that make and distribute products between the farm and the customer. Now, in this section, there is a huge scope of growth rate and that can affect in the success of your startup. Now, I would like to tell about something about the consultancy firm, opening a consultancy firm. As a mechanical engineer, you can open up a consultancy firm. Yes, it is true that at first it is hard, but as you are going to do the hard work, as like in the understanding of the budget, by increasing the personal bandwidth with the clients, with the successful entrepreneurs, you can easily do and you can easily deliver best result to your clients. Now, I would like to tell Bijit, please move on to the next slide. Okay, here are the pictures, and I think all of us know these persons as their groups are directly linked up to our life in with our everyday life. Like the man who is here, Mr. John Rockefeller. He is the father of the oil industry business, as we all know that he at first started the invention of refining the petroleum from the crude oil. Now the second one is Mr. Charles Koch. Charles Koch is an American businessman and philanthropist. He is also a mechanical engineer, and I would like to tell you all that that is not mentioned here, that the total asset value as per 2020, Koch Industries total turnover and asset value is near about $115 billion, and they works upon refining and distribution of petroleum. Not only these foreigners, our Indians are also here, like Jahangir Ratanji Dadabhai Tata, or in short, he is JRD Tata. We know that Jamshedji Tata was the founder of Tata Group, but in future, JRD Tata, who is also a Bharat Ratna, has bring forward the business of Tata Group, and he has expanded the Tata Group to globally. And we all know that in our everyday life, from teeth to toe, Tata is everywhere. Please, Bijit, next slide. Bijit. Now I'd like to tell about Mr. Henry Ford. Henry Ford is the founder of Ford Motor Company, and he just started the Ford Motor Company business with just $28,000. But recently, in today, the Ford Motors total annual asset is rupees $228 billion. Now the next one is Lakshman Rao Kirloskar. We all know about the Kirloskar group and the Kirloskar pumps. It is an interesting fact that our college TECB also uses the Kirloskar pumps in our mechanical workshop. Now we can easily say that how much visionary he was, that he invented the Kirloskar group, and we are being we are getting the fruit from his company. Now the interesting fact is Mr. Ankit Bhati, who is mentioned here. Ankit Bhati is a mechanical engineer, but
Mayuk, Mayuk, let me
uh,
interrupt. It's going a lot of in here. Please conclude it here. Kindly conclude it here. This is end.
okay, okay. So, Mr. Ankit Bhati, there is an interesting fact I would like to tell, and then I will conclude this. He is the founder of Ola Group, and though he had though he had done the mechanical engineering, but he started the app-based cab service, and we can easily say that if you are from a core stream, then it is not that you are binded to that core stream. You can easily switch over to any kind of industry. Bijit, next slide. Bijit. Okay, so that's all from our group, and I would like to thank all of you, and that's all.
Okay. Thank you, Team Make Tech. And